didn't actually get.
I missed something else this
I love it when I'm like surprised. Number one was worth 5 points and the rest were worth 6. So take a minute to look at it and we'll go over whatever you need. Definitely we'll do number 6. Yeah. I was like,
I didn't get that one from like I have a question. For future tests, can you put like how much the questions are?
I can try. I usually don't decide that until after the fact, but yes, I can try. Okay. So, were there any questions on the front? Oh, yeah.
I totally forgot to do it. Like, you know when we were gonna get a y component? And I did like the equation, but I totally forgot what to put in as the DIY.
You don't have a DIY because it's 0.
So it's just like what, gravity
So-
times time?
1/2 gravity times time squared.
Oh my god.
I still got this one right.
Because the first part of that is the DIY times the time, which we don't have a DIY because it's horizontally long. Other questions in the front? Okay. Questions on the back, other than anything other than number 6? Okay, for number 6, I think Lauren was the only one that got it right, and she's not here. So it was 2 points, basically 2 points for the answer and 4 points for your work. And depending on your work, if you were doing the right things, I was looking for a couple things. First, I looked to see if you used the quadratic formula to find the time. If you did that, I gave you points for doing that, but a lot of you did it and didn't get the right answer, so I'm not sure what happened with that. And if I was also looking to see if you, for the final velocity, if you found both of the components of the velocity, and then we're looking at the resultant. So if I saw that you were doing that, then I gave you a point for that. So I think the most anybody missed was 4, and that's if you didn't get the answer right, that's 2, and if you missed both of the, if I didn't see the Pythagorean theorem, or not, sorry, if I didn't see the quadratic formula and the final velocity with the resultant drawn, those were each 1 point that I took off of it. I couldn't see that on your work. Okay? So let's do it. So we know the, I guess, we know the dy is negative 1.5. It's going down 1.5 meters because it's originally launched from a height of 1.5 meters above the ground. And we also know that it's 12 meters per second at 30 degrees. So you should have gotten, I think everybody was pretty much fine with this, but you should have gotten the initial horizontal velocity to be about 10.4 and the initial vertical velocity to be, that was exactly 6. Did everyone get that right? Okay. So then, since we know the dy, we can use the dy equation. And so we have negative 1.5 equals 6t plus 1/2 times negative 9.8 times t squared. So negative 1.5 equals 6t minus 4.9 t squared. And then you would need to get that all onto one side equal to 0. I would probably move it to the left just so that my a term is positive, but you could do it either way. So 4.9t squared minus 6t minus 1.5 equals 0. Questions? Okay, so t equals 6 plus or minus the square root of 36 minus 4 times 4.9 times negative 1.5 divided by 2 times 4.9.
How come we have to use that to find the time?
That's what I was wondering too.
And not like, why couldn't you just use the DIY time like we normally do? Don't we use something?
Because this problem is exactly like number 6 on the review. And we said if it's not symmetrical, then you can't do that. Because that time formula is coming from the fact that the initial and the final vertical velocity are both, it's coming from the initial vertical velocity being 0. And no, it's coming from the displacement being 0, the vertical displacement being 0. Because if we start and end up at the same point, which is usually what happens, and that's what happened in the other angle launch, number 4, then that's why we can use the time formula, the 2VI divided by G. But if it's not symmetrical, in this case it's up 1.5 meters above the ground, so now we have a vertical displacement, we can't use that formula, which I thought we discussed right before the test, right before the quiz yesterday.
Yeah, we
To try to refresh your memory.
Well, I just didn't know because of any problem that we practiced, we never did that. That's why I was confused. Like any problem
We did in the calculator pad, and this, like I said, this exact same problem was on your review. I only changed the numbers. All of the words were the same as the one on the review. But that's why you need to do that. And so the time is going to be 1.437 when you type all that into your calculator. There would also be a negative answer, but obviously we need a positive answer for this time.
Can you type that all in and get that number?
If you type it in right.
I didn't type it in. But what about the plus and minus? How would you type that in?
Well, you'd have to do it separately. So you'd have to do it one time with plus and one time with minus.
When you add it?
And no, you would get 2 answers, but one of your answers is going to be negative, and we can't have negative time, so we go with the positive one. I didn't even write down what the negative answer would be. Okay.
Should have done.
Other questions?
Can you do me a card?
Oh, we're not done yet with this.
Oh, okay. I forgot. I'm
But
sorry.
then, yeah, thank you. So that's the time, and so then to find the horizontal displacement, it's the initial velocity times time. So the 10.4 times the 1.4, and that gives you 14.94. And then we have to find the final velocity. So the final horizontal velocity is going to be the same as the initial horizontal velocity, so that's going to be the 10.4. And the final vertical velocity is the initial plus GT. So that's 6 plus negative 9.8 times 1.4. And so that's negative 8.08, which basically tells me the direction. So it's going down 8.08 over 10.4, and then you have to find the resultant. So that would be the square root of 10.4 squared plus 8.1 squared, whatever it is. And that gives you 13.2. Okay,
Mhm.
questions?
It's funny because I got like negative, or no, negative 6 plus or minus the square root of 8.08 in my like quadratic formula.
Oh,
Correct?
hmm,
It's kind of weird. Maybe it's just a coincidence.
probably. Alright, does that help with 6? Yes? Okay. 5 was the one that you guys were talking about, where you had to convert units. So they give you dx is 1.8 meters, and they also give you dy, but they give it to you in centimeters. So we would want to convert that 110 centimeters, there's 100 centimeters in a meter, and so that would give you 1.1 meters. And then they'll both be in the same terms. So to find the speed, we first need to find the time, which we can use dy equals 1/2 gt squared, because this is a horizontal projectile problem. The initial vertical velocity would be 0. And so 1.1 equals 1/2 times negative, well, you do positive 9.8 in this case, times time squared. So divide both sides and take the square root. So time would be square root of 1.1 divided by 4.9. And then use that in the dx to find the initial horizontal velocity. So 1.8 and that will give you 3.8 meters per second. Okay? Other questions? No? Other questions? Okay, I will take those back. And if you would get out your notes, please. I was sad you didn't do it.
Hey, I was going to, and then it
Lauren's gonna
didn't
be like,
make
"What
sense to
happened?"
me, and I was gonna do something that didn't make sense, so I just didn't do it.
You didn't understand why.
No, I didn't really get to look at the paper that much.
I can understand the entire concept of number 6.
I just remember we had to use the quadratic formula. It's like, okay.
Well, I don't think it hurt you guys too bad, but
I'm sorry that it was
surprised. Alright, we're gonna talk about the forces, the addition of forces. We talked about forces a lot back when we were talking about Newton's laws, and so we need to review those. So before I pull this up, does anyone remember Newton's first law?
Objects
I
in
really
motion
can't.
stay in motion, objects stay less and less active on an unbalanced force.
Fine.
There you go.
I'm gonna say it, but fine.
Very
Don't
good.
raise your hand.
What about the second one?
Would you like to take that one?
Every object has equal and opposite reaction.
That is the third one,
Oh.
actually. The second one doesn't really roll off the tongue like the others. It was the one that says that the acceleration of an object is inversely proportional to the net force of the mass and directly related to the mass and acceleration. Yeah, I didn't think you were gonna remember that one. But that is going to come into play. So the first law, maybe you don't even need to write down, because it sounds like you don't have it memorized. But the second law, we definitely need to refresh our memories on, and that's acceleration, the net force, and the mass of the object. And the relationship between those three could be written in two different ways. So equilibrium is when all the forces are balanced, so that's pertaining to Newton's first law. So if all the forces are balanced, then the object will continue to do whatever it's doing. So that's when the net force is equal to 0. So there could be forces acting upon the object, but they will all balance out if it's at equilibrium, and then it will be continuing to move in the direction that it's moving. If objects are accelerating, what's the technical definition of accelerating?
Speeding up, slowing down, or changing direction.
Good. So there's those three things, meaning that the velocity is changing. So it could either be speeding up, it could be slowing down, or it could be changing direction. Very good. So in that case, the forces would not be 0 because they would not be balanced. And so it will have an acceleration if it's not balanced. And so when we talked about this originally, all of our net forces were either straight up and down, straight left, right, so all in the straight directions. I'm not speaking very clearly, but you know what I mean. They were either vertical or horizontal. Well, now that we have done all this with vectors, we'll be having forces and net forces that are at angles, so we can determine the acceleration also if it's at an angle, which is more likely that that would be the case in real world situations. So we can use vector addition methods to determine the sum of the forces and the acceleration using the second law equations. Okay, we're gonna get more into that tomorrow, but today we're just sort of reviewing what we learned about the force. Okay, so let's go through the multiple choice and see what we remember about that.
Is Tom Henderson the guy that like does the recording stuff?
Before we do that though, what would you say that it would be if I said, what's 10 newtons plus 10 newtons?
Yeah.
0? 20?
I mean, I feel like it's a trick question.
Which direction are they going?
Very good.
Yeah.
Where is this? Oh, here we go. That's exactly the question that you need to ask, okay? And good, I'm glad. So when we have two forces, it all depends on the direction. So 10 newtons plus 10 newtons could be 0, it could be 20, it could be 10 if they're going in the right directions. Okay, so very good. I'm glad that we're good with that. So which one of the phrases does not match the meaning of the other three phrases? Net force, resultant force, acceleration, and vector sum.
No.
That's what I was saying.
How do you net?
B, I think it's B.
Would be net? Because the resultant and the acceleration and the sum of the vectors are all the same thing.
I don't.
Trick question.
It's not a trick question.
Okay.
This isn't a trick question.
Is it B?
It's acceleration. Acceleration is not the same, right? Acceleration
So
is
speeding
S.
up or slowing down.
It's not force.
Well,
It doesn't.
Which one doesn't mean the same as all the rest?
Yeah.
I was just thinking about what we just talked about and picking the one that wasn't in our notes.
Okay.
Okay, so net force. Net force, resultant force, and vector sum are all the same thing. Acceleration would be the one that would be different. Which of the following is always true of an object that is at equilibrium?
The net force is zero.
C?
Maybe. I think it's B.
There's
more than one possibility.
Then net force is
B?
0.
B.
Yay. Oh, there's more?
D?
A? I think so. No.
D?
Yeah, it doesn't have to be at rest, right? Because it just is gonna continue doing what it's been doing. So if it's already in motion, it will stay in motion. Okay, Kent, remember, added two vectors and drew the resultant. However, Kent failed to label the resultant on the diagram, which is the resultant.
And
No, it's
no,
no,
C.
C. Good.
Why is it C?
Because we add them head to tail, and so you have to look at which ones are lined up head to tail, and then which one starts at the, I never remember which is the tail and which is the head, but which one starts at the end of the one and goes to the tip of the other one. So this is the same question, so which one of these would be the resultant? Good, so C and A are head to tail, and B would be the resultant of this. Good. Consider the 5, match the sums to the estimated direction of the corresponding resultant. One of the choices does not match, placing the trash can. So A plus C plus D would look like which of these down here? The first one? Okay. Let's not put them up there yet because it blocks it. B plus E plus D.
I don't know how to do this.
I don't know what we're doing either. I don't understand.
Okay. A plus C plus D.
Oh, are you looking at the resultant of
Yes.
it? Oh, okay.
And obviously that's a sketch, but it would look like,
Straight.
it looks sort of straight, which there isn't one. So let's do B plus E plus D. So B plus E plus D. So the resultant, that one would be obvious. That one would definitely be going to the right. So that one would be the first one. The second one I'm not so sure, my picture isn't good. It must be the other one because it has to be going up. It must be going to the left and I didn't draw it very nicely. Okay. So we're just sketching. So if we sketched these and did C plus A plus B,
Last one.
and B plus E plus C.
Be the first one.
First one,
Good. Which of the pairs of the force vectors below would add to give a resultant that is pointing into the first quadrant? Or between 0 and 90?
How are you putting them together?
Head to tail.
Like in the position they already are in? You're just like
Mhm.
touching it?
The third one?
But
The third one? The last one?
You have two choices.
There we go.
if you put them head to tail, so they do need to stay in the directions that they're pointing, but you have to shift them so that the tail of one is at the head of the other one. Which one? That would be the last one. Can you see it?
Mm-hmm.
Okay. Which one of these would be pointing into the second quadrant? Yes. Good? Can everybody see it? Yes. Okay, which of the pairs would add to give a resultant that's pointing into the third quadrant?
The first one.
That's first. I think it's the third.
That would be the fourth quadrant.
The third one?
Yeah.
Good. Okay. Let's stop. Alright, so I want you guys to review forces and force diagrams. This I don't think should take you very long. Do you remember the force diagram, the different forces? Maybe. The first one is done for you. The directions are that you need to draw and label the forces acting upon the objects, and so that they will experience the acceleration that they give you. And you have to add at least 2 forces onto the graph.